Okay, so let's see whether or not I can get this one correct. Now, we've got an algebraic fraction question here. So we've got 4x minus 1 over 5 plus x plus 4 over 2 equals 3. Now, what I said last time about forgetting this equals 3 over here is exactly right. We're just going to forget about it and we're going to simplify the left-hand side. So, the way we do this is we multiply the left side by 2 on the top and the bottom. So 2 times the top gives us 2 lots of that bracket. 2 times the bottom equals 10. We then multiply the right hand side by 5. So 5 lots of this bracket and 5 lots of 2 on the bottom is 10 equals 3, but like I say, we're forgetting about the 3. What we're then going to do is multiply out and simplify the brackets. So if we multiply out and simplify the brackets here, 2 lots of 4x, 2 lots of minus 1, so it's going to be 8x minus 2 over 10. If we do the same with the right hand side, we've got 5x plus 20 over 10. Again, that equals 3, remains there. What we're then going to do is we're going to simplify. So we're going to do 8x plus 5x, which equals 13x. We're going to do minus 2 plus 20, which is going to be plus 18. So we end up with 13x plus 18 over 10. And that still equals 3. What we then do is it then just turns into an algebraic equation. So what we need to do is we need to get rid of this divided by 10. So we do the opposite to the other side. So the opposite of divided by 10 is multiplying by 10. So we multiply the other side by 10 to get 30. And if we've got rid of that divided by 10, we are left with 13x plus 18. The next thing we need to do is we need to get rid of this plus 18. So we do the opposite again. So the opposite of plus 18 is minus 18. So that's going to be 12. And if we get rid of that 18, we're left with 13x. Now if 13x is equals 12, what we do to get rid of the times by 13 is we divide by 13, so we end up with 12 over 13. And that, boys and girls, is the correct answer to that question. Okay, moving on to question 18. We've got a question which is all about reflections and then a single transformation. I'll talk more about the single transformation in a second. But to start off with, we've got to reflect shape P in the line x equals minus 1. Now, to start off with, we need to know what the line x equals minus 1 looks like. So, this here is the line x equals minus 1. And the reason it's the line x equals minus 1 is because it goes through the x-axis at minus 1. So the line y equals 7 would go through the y-axis at 7. We don't need to know that for this question, but that's why this line is x equals minus 1. It's because it goes through the x-axis at minus 1. Now the secret with reflection is just counting. So if we consider all 4 points of our shape here, if we take this point first of all, that's 2 squares away from the line of reflection, so we're going to go 2 squares the other side. So it's going to be reflected to that point. This point here is 2 squares away from the line of reflection, so if we go 2 squares over, we get this point. This point here is 1, 2, 3, 4 squares away from the line of reflection. So we go 4 squares the other side. 1, 2, 3, 4, and that gives us right here. And finally, this point down here is 1, 2, 3, 4, 5 points away. So we're going to count 5 the other side. So 1, 2, 3, 4, 5 brings us here. And if we join that together, that's a reflected shape, and we call that Q. What we've then got to do is reflect shape Q, which we've just drawn, in the line y equals 0. So the line y equals 0 is the line that goes through the y-axis at 0. So what we're going to do is this line here goes through the y-axis at 0. So we've got to reflect it in that red dotted line there. So this point here is 1 away, so we're going to go 1 the other side. This point here is 1, 2, 3 away, so 1, 2, 3 down, gives us that there. This point here is 1 below. That's going to go there. This point here is 1, 2, 3 below. So 1, 2, 3 below gives us this point here. We end up getting that there, which we're asked to call shape R. And then what we've got to do is describe the single transformation that goes from P, which is this shape here, to R. So how do we get from this shape here to this shape here? Now when it says single transformation, that can be one of 4 things. It can either be an enlargement, but ours has been made bigger, so it's not going to be an enlargement. It's either been a reflection, well, it's been reflected twice, but to get from P to R, that's not a single reflection, so it's not going to be a reflection. Has it been translated? Now, translated simply means being picked up and moved. But so it hasn't been picked up and moved to there because it's not the same direction, so it's not a translation. What's happened is it's been spun around, so it's been rotated. And you're going to get 1 mark for using the term rotation. Now, it's actually been rotated 180 degrees because it's not a quarter turn, it's a half turn. Then what we've got to do is we've got to find the point of rotation. Now, the way we do that is we use tracing paper. And if we use tracing paper and we put our pen there, and then we spin it around, point P ends up, if you spin it around 180 degrees, matching or mirroring onto shape R. Therefore, it's been rotated 180 degrees. So rotated, 1 mark, 180 degrees, the second mark, and through point -1, 0 as the center of rotation. I guess our 3rd mark. Okay, so the next question, question 19, you have to work out angle DOA. Now this is worth 3 marks, this question. So what you need to do is you need to start writing anything that you do know. Now we should know that a tangent, which is the line BC here, meets OB, which is a radius. So when those two meet, they meet at right angles. So if we know this is a right angle, and this here is 34 degrees, then we've got a triangle here. And one thing that we should know is that angles in a triangle add up to 180. So 34 plus 90 degrees equals 124. If we take 124 away from 180, we end up with 56 degrees. So this angle here is 56 degrees. Exactly the same, we should know that if this is 34 degrees here, this one's going to be 34 degrees. This is also going to be a right angle, so using exactly the same maths, we should know that this is 56 degrees as well. Now, angles on a straight line, because we have a straight line here, we've got the diameter. Angles on a straight line add up to 180. So so far we've got 56 plus 56, which adds up to 112. So if this is 112, this must make it add up to 180. So 180 minus 112 equals 68 degrees. So angle DOA, and the reason that is DOA is because it goes from D to O to A, and that equals 68 degrees.